Okay, this is AP Pre-Calculus 2025 FRQ questions. I'm going to go over the sample answer for number 2. It says a musician released a new song on a streaming service. A streaming service is an online entertainment source that allows users to play music on their computers and mobile devices. Several months later, the musician began using an app at time t=0 that counts the total number of plays for the song since its release. A play is a single stream of song on the streaming service. The table gives the total number of plays in thousands for selected times t months after the musician began using the app. At t=0, the total number of plays was 25,000. At t=2, the total number of plays was 30,000. And at t=4, the total number of plays was 34,000. The total number of plays in thousands for the song since its release can be modeled by the function d, given by d of t is equal to a t squared plus bt plus c, where d of t is the total number of plays in thousands for the song since it's released, and t is the number of months after the musician began using the app. A, part 1 says use the given data to write 3 equations that can be used to find the values for the constants a, b, and c in the expression for d of t. So right here for part A of part 1, we know that d of t is equal to a t squared plus bt plus c, and on the table we're given essentially 3 points that we can plug in to find the 3 different equations. So the first one would be 25 is equal to a 0 squared plus b times 0 plus c, which means c is equal to 25. Then we have 30 is equal to a times 2 squared plus b times 2 plus c, which gives us 30 is equal to 4a plus 2b plus c. And then we have 34 is equal to a times 4 squared plus b times 4 plus c. So this means we have 34 is equal to 16a plus 4b plus c. Part 2 says find the values of a, b, and c as decimal approximations. Well, for A part 2, we already know that c is going to be 25. So if we plug in that value, we have 30 is equal to 4a plus 2b plus 25, and 34 is equal to 16a plus 4b plus 25. We could graph these equations to find the intersection, and once we have the intersection, then we will get our decimal approximations for a and b. So a would give us negative 0.13, and b is going to give us 2.75. Okay. B part 1 says use the given data to find the average rate of change of the total number of plays for the songs in thousands per month from t=0 and t=4 months. Express your answer as a decimal approximation, so show the computations that lead to your answer. So for B part 1, I'm going to use the average rate of change formula. So I'm going to do d of 4 minus d of 0 divided by 4 minus 0. And then looking at the table, I can plug in my values. So 34 minus 25 over 4. And this gives me 2.25 thousandths per month. Okay. Then for B part 2, it says use the average rate of change found in B part 1 to estimate the total number of plays for songs in thousands for t=1.5 months. Show the work that leads to your answer. So for part 2, I'm going to do d of 0 plus my average rate of change of 2.25 times t. So d of 0, looking at my table, is 25. So 25 plus 2.25 times t equal to 1.5. I get 28.875 thousands. Okay. And then for B part 3, it says let A of T represent the estimate for the total number of plays for the songs in thousands using the average rate of change found in part B, part 1. For A of 1.5 found in part B, part 2, it can be shown that A 1.5 is less than D of 1.5. Explain why in general this is true for all T, where T is between 0 and 4. Your explanation should include a reference to the graph of D and its relationship to A of T. Okay, so for B part 3, I would say that A sub T is less than D sub T, because if we look at the graph, D of T is concave down for 0 less than T less than 4. And since it's concave down, this tells us that this D of T value is going to be greater than our A of T value. Okay, and then part C. Part C says the quadratic function model D has exactly one absolute minimum or one absolute maximum. The minimum or maximum can be used to determine a domain restriction for D. Based on the context of the problem, explain how the minimum or maximum can be used to determine the boundary for the domain of D. Okay. So since D of T is quadratic and concave down, the domain is based on the maximum value, and since T is time, it has to be larger than 0, so the domain would be 0 less than T less than the maximum value, whatever that value may be.